Okay. All right, we're going to work through the practice exam on this part on the video. I'm going to do the multiple choice. Okay. So let's look at number one here. Which of the following is not true of the Bitcoin transaction process? After the transaction is verified by a node, it becomes part of the blockchain. Well, is this true? No, it's not part of the blockchain at that point. It just means it's approved and miners can pick it up, and add it to their block here, when they're trying to add to it. It it's still at this point is not completely processed. Like it just means, okay, this is valid. It needs to be picked up still though and added to, you're still not through that process. It just becomes part of the meme pool. After a transaction is picked up from the meme pool, it becomes part of the blockchain. But no, not yet. Just because a mining pool gets it and starts trying to add it, it still is not added yet. All right, it needs to be picked up, put into the block header as part of this transaction, make the Merkle root out of it. But there still needs to be a hash created with it, accepted, and then added, as a new block on the blockchain. There's still some parts of it left yet. It's still not completely through as far as being added. Okay. A transaction can have multiple inputs and outputs. So that's true. All right. So D is going to be the answer here because A and B are just given part of the process. All right. It needs to be verified by node to make sure it's legit. This person has this money. Then after that, it becomes part of the meme pool. Then after that, it's going to be picked up, and added to this block that's trying to be created. But at that point, it still needs to a hash needs to be created from it, from the block that when someone's picked it up and put it in it, it needs to still be processed and added to the blockchain. It's still not completely there yet. Okay. So let's say the current difficulty for creating new blocks on the Bitcoin network has this threshold value, and let's write this down: 0, 0, 0, and then a bunch of Fs. Okay. Circle the following hash values for the block that would be acceptable. So there could be more than one here. So A, what does it have? It has 2 zeros and an A, 401, and so on. Well, this is no good, right? It needs to be less than this value, right? And so since you have this A right here in the third spot, that's higher. You can think of that as like an 11. This is hexadecimal. There's 16. You got 0 through 9. Then you have A, lowercase a through F. So that's higher than that 0 here. So this is going to be too high. So it's not going to be A. What about B? A, 07, 041, and a bunch of other letters. Well, right away, the first slot here, you have an A, which is higher than 0. So this is well above this threshold here. So it's not acceptable either. C, 0, 0, 0, 191, DC, 1790. Will this work? 0, 0, 0, and then 1. All right, so this is lower than this number right here. So this would be acceptable. All right, that's going to become part of the blockchain. D, 0, 0, 0, it's like 6 zeros, 1, 0, 1, 1, 1, 0. Yeah, this is well below it, right? You got 6 zeros here. So this number is well below this. This would be acceptable too. Okay. All right, so it's C and D there in that case. So Brian is starting up a new business selling gym equipment. He is thinking of accepting cryptocurrency, and the grammar there is wrong. He is thinking of accepting grammar. He does not plan on using the Lightning Network. Which of the following could be a problem for him? A dissatisfied customer putting a hold on transactions shortly after it was made. Well, this isn't going to be an issue for him, right? Once this is a currency, once the transaction is made, the transaction is over with. There's no counterparty risk. Purchase is made for a small amount. So this is kind of a big deal because it takes a while if you're just using the Bitcoin network to make sure that the transaction is actually going to be processed. Okay, so this isn't ideal for small purchases being made. Now, somebody wants to, make a large purchase online, that's fine. It can, they don't have to be made really quickly. The process has all night for it to take place. That's not really a big deal here. But for like going in and making these small purchases, like doing them real quickly, that's where the problem's going to be at here. Okay. It's going to be B. That's going to be the issue. Purchase made for large amount. That's, when you're making a large purchase, it taking a little while is not too big of a deal. Okay. Like I said, some big online order, that's not really too much of an issue, but anything that needs, it's not going to be made really quickly. Now that's where the Lightning Network's supposed to come in. Kind of that article we looked at. That's kind of what they're using in that's what they're using in El Salvador, but they're still running some issues with it, right? It's supposed to be quicker, but a lot of times it's not working correctly. But in theory, it should be something that once everything's worked out, it should be able to work most of the time. If the average time creation for a block is 9 minutes, the algorithm will blank the difficulty of block creation, blank the threshold value of the hash requirement. So if a block's being created every 9 minutes, that's too quick. It's too fast. Right? It's too easy with the amount of hashing power on the network to create, add new blocks and get new Bitcoin rewards. So what's going to happen is the algorithm, after about 2 weeks or however long it takes for if it's done, it's going to increase the difficulty because it's too easy. They're making them too quick. All right. This threshold value they have, it needs to be lowered, right? You lower this threshold value, that means there's less possible, hash values that will like meet this qualification. So it means that they'll on average add more tries that need to be done. And the fact that there's too much hash power for the current difficulty, they'll lower this to make it more difficult, and that'll increase the difficulty and slow the production down, get it back on track to around 10 blocks per minute. All right, and so that's actually A. 5. The Wojak coin is a cryptocurrency without a cap and no adjusting algorithm. Additionally, it incurs a non-trivial amount of currency loss each period. Elon Musk just talked about the crypto asset on Twitter. As a result, the demand for the coin increases. Initially, the price will what? Well, it's going to increase because it's increased demand for it. Okay. So it's going to increase. The entrepreneurs will react to the change in price and cause the price to slowly decrease. There's no algorithm to impact them. The fact that this value, this Wojak coin is worth more, it's going to attract more miners. They're going to spend more, electricity. They're going to do this. Some of them maybe that weren't worthwhile to do it before. Now that it's worth more, it's worth their while. So it's going to increase the hashing power of this. So it's going to increase, the supply. And when this increase in supply here is going to slowly lower the price. All right. So it's going to price to slowly decrease. Let's assume that it was in a stable price, steady state before the demand shock. The long-term price, once it establishes equilibrium again, will be slightly higher. Okay. That's because coins are going to be added, so the supply is increasing, and that means that we're assuming here that the rate of token loss is the same. That means you're going to need to have a little bit higher price to provide enough incentive for these entrepreneurs to replace the tokens that are being lost each period. All right. So this price is going to be slightly higher than it would have before here. Okay, so that's actually going to be C here. All right, 6. Jill has just joined the F2 pool mining pool. She will share earnings with everyone in the mining pool. However, she will still need to run her own full node in order to have access to the transaction meeting pool. This is one of the benefits of joining a mining pool. You don't have to run a full node here, like to have access, to process, to make sure these verify these transactions, to make sure they're legit, or to have access to the spin pool. You can just, use the mining pools node here. They'll provide all this for you here. So that's going to be false. Okay. All right. Number 7. Suppose a financial asset has a 15% chance to earn $50, 85% chance to earn 500. What's the expected income? Well, the formula for this is probability of earnings one here times the value of this random variable I, because it's going to change random. And this probability two, let's not just because it kind of depends here. It's not always that. So let's do this. And probability two times the value of this income, this other state that has potential to be here. Okay, so we have two states here, two different probabilities. 15%. The value is $50 there. Plus the probability, 85%, that the value is going to be $500. Okay. And so what this will come out to be here, if you multiply this together, is going to be $432.50. Okay. All right. Let's see here. Number 8. In the process of adding blocks to the blockchain, a miner will use the information for the latest block as input for a hash function. If the hash value is blank, the threshold, the miner will adjust and try again. All right, so this is when it doesn't work here, okay? So if the hash value is above this threshold, all right, it needs to be below this threshold value for it to qualify. So if it's above it, it's no good. The miner will have to adjust the nonce. It leaves all the other information the same, all right? You know, the threshold value, the rules that it's following, this Merkle root from the transaction, all this stuff is going to leave the same, but it'll adjust this nonce here. You know, keep adjusting that until it meets this threshold, or somebody else gets it and they start on the next, try to add the next block on the blockchain. Okay, so that's actually B. Patrick Bateman has just made a large purchase of derivatives in the over-the-counter market using Bitcoin. Before he made the purchase, he got with some friends who own a large Bitcoin mining pool. In exchange for some insider information, he wanted them to carry out an attack on the Bitcoin network by creating another version of the block with his Bitcoin transfer. All right, so that, you know, in this version, what he's saying is like, okay, instead of sending to this person to make this purchase, I'm going to send it to a different address here. Okay, so assuming the insider information is worth as much as the Patrick's Bitcoin, what percentage of the Bitcoin's network's hashing power was friend need for this to be worthwhile? Okay. All right. So he's, like I say, he's promising to give him some inside information in order to carry out this attack here. So anytime for it to be worth your while for this network to conduct an attack, they need to have over 50% of the mining power. So this is always going to be C here. All right. Otherwise, it's just not worth it, because if the attack doesn't work, and so if this is below 50%, it's not likely it's going to happen, not likely it's going to work. And so you'd be spending all this effort here trying to pull off this attack, and you'll get no reward for it. It's really expensive to pull off. That's the way this Bitcoin consensus algorithm, the way it's set up, this proof of work, it punishes you indirectly if you try to cheat, right? Not directly. Okay. As we'll see later on, some of these proof of stake, you get punished directly with those if you get caught cheating. All right, but this, what's kind of neat about the Bitcoin is like it does it indirectly. Like they don't, you know, somebody may not even know you've done it, but like if you try to pull it off and it doesn't work, well, you're out all this money that you spent that you put in the electricity trying to pull it off here. Okay, so it punishes you indirectly here. So let's see. 10. Brian, Jessica, and Tyler trying to make a Bitcoin transfer at the same time. They all plan on leaving the same transaction fee tip. Okay. Brian is combining a lot of small unspent transactions to send one address, but the size of the transactions are small. Jessica is sending one unspent transaction to one address, but it's a large transaction. It's a lot of Bitcoin or a lot of Satoshi. Tyler is only using one unspent transaction, but he's sending to multiple addresses. That is, there's multiple outputs. Which transaction is most likely to be added by the miners here? Well, this is going to be Jessica, C. Why? Because what matters here is bytes of information. Okay. The more bytes of information, the more room it's going to take up space, and that means the less transactions that these miners can add here. That's what they're concerned about. It doesn't matter how large it is. That doesn't take up space on the block that's being added. That doesn't count against it. What matters and what counts against, the size that they can put on each block is, the number of inputs and outputs. The more information with that, the more bytes it takes up, and the less of them they'll be able to add. Right? This is what's kind of neat about it. It's like, you could make a really, you could send a lot of money here, and it's going to be the same as if you were sending a small amount, if it's the same number of transactions, like inputs and outputs associated with it. Right? Like I said, that's going to be Jessica here. Just one spin on transaction, so one input and one output. All right, send it to someone here. So that's it for this first part here. Hope this was helpful.